for the reader of the class. It's not a specific type in C++. Be aware, my iterator type, you can call it whatever, type name or class, and you give it here a name. The only condition for that name will be to be able to move through each element forward and read the data in that location. So our function will work for all iterators which are output iterators, because we need values there. And we specify begin and end. These are names you choose. It should be of this type. And this is exactly what we have seen before in terms of code. No specific change happens. But with this approach, we can use our min function to vector like before, to double-ended queue, because this provides random access, which is an output iterator. List is bidirectional. It's more powerful than an output iterator. Therefore, our function template will work with list. And you can see with one function we can perform polymorphic vectors, work with vectors, double-ended queues, lists, and any container providing output iterator. In order to perform operations or like printing data or reading data from constant containers, if they are constant, as I said, if the declare is constant, then the iterators shouldn't be able to modify the elements. Therefore, the C++ committee has introduced this constant iterator that does not allow changing data. You can dereference with that iterator, but just to copy values from there, not change values there. So, constant containers are, in this way, available for various tasks. Like in this example, we have a constant vector passed to this maximum. What we want, to get the largest value in the vector. Therefore, we have no business on changing the element. And in order to work on this constant, we have to declare our iterator of this type, set it to that value, and then max value to 0, which is not the best approach, and then go till the end of the iterator, compare what it was read with the maximum so far, and if the current value is larger, we set the maximum value by copying and move to the next location and return what we get after we finish the while loop. Now, I said that it's not a good idea to set it to 0. This vector can have negative values, all negative. So I can have a constant vector with -3, -5, -9. Maximum value is -3, not 0. What is a small change you have to do? Set this to the first element in the sequence, dereference IT. Dereference IT sets the maximum value to the first element. And in this way, then you compare with every element and you end up with a proper maximum value. This works only if you have positive values in this method, which is many times presented in books and stuff, does not work if you have this kind of vectors. It gives you definitely the wrong answer if you have this vector. -5, -3, -9, -1. The maximum would be -1. Setting max value to this, the reference IT, and then do it like this, it's okay. And it will give you the correct value. Right. But you have seen, for example, how to use constant iterator and why they are updated. And you have to be aware that it's a difference between constant iterator and an iterator which is constant. Things become more exciting, right, by combining things. So with a constant iterator, the code promises not to change the element to which it looks. This is not allowed. But you can change the iterator itself because you move through the elements. It's constant because it doesn't change the element in the container. With an iterator which is constant, you are not allowed to move through the container. You are stuck to some location, the beginning, but you are not allowed to move the iterator itself. You are allowed to change the elements in the container. Right, so this was just an interesting thing to be aware of. Now, when we talked about for loops, for ranges, probably you remember, it is a very good for loop to use when you have to work with a whole set. In that case, you can use a variable to access the whole set, being it a C-array, a vector, and any container. Double-ended queue is also good to work in this way. You can have a double-ended queue here. And you don't worry about going outside the array, because with this notation for ranges, you start at the beginning of the container and you end at the last significant element, because iterators are behind. Now be aware that with this notation, you introduce a variable in this scope. I, it's a variable which is matching each element in the array, not the index, element itself. And because it's a new variable, you can pass it by value or by reference. If you pass it by value, any changes which are here are not available outside the for loop. Be aware. If you pass it by reference, like here, any changes you do to your elements are available outside for loop. So with the first for loop, we set up the values in array, and those values stay there. Now, the same code applies for vectors and for the double-ended queue, as I said, and for lists. You can use it. Now, you can think that behind this type of for loop is something like this iterator. This is not proper code. It's not proper code. It's something like this. It's a little bit more complicated. An iterator which sets I to the beginning of our vector and goes till the last element, whereas comparing if begin is not end, we move goes behind the scene. And if a data structure does not have corresponding items to an iterator pointer, then you can't apply for C arrays. Pointers in C are the most primitive type of iterators, and all type of containers are available. And here is a full program. We include vector. First, we construct the vector element with I times 5.